Okay, so how do I actually tell if I have a good element quality or not? I can kind of look at it and see, most of these are pretty regular triangles, but, there's so many of them. I've got 80,000 elements. So the tools that we use to help identify bad elements is this model data contour command. And if you don't have it on a toolbar here, you can go to View, Advanced Post, and there it is. To help clean up my view a bit, I want to get rid of these surfaces, these curves, all this stuff, get it out of the way. I'm going to go back to Visibility. So that was a command I showed earlier here, View Visibility or View Visibility. I'm going to turn everything off except my elements. Makes for a little cleaner view. Now we'll use this model data contour command. And this is a really useful tool. There's lots of different applications here. You can contour all different types of information on your model. So I recommend kind of digging in and looking through the different options here. But what we want is to contour the element Jacobian. That is a good indicator of element quality. And we're going to turn on Allow Labels, so it'll actually label our highest Jacobian, which will be our worst. And there it is there. So you can see this contour scale, lowest being the best quality elements and highest being the worst. So we can kind of rotate around. And there's that train again. See that small sliver there? Let's turn on our curves. And I'm going to go ahead and try and fix this nasty little area right here. And I'm doing that with the meshing toolbox. So it's a window pane here. And say we just want to try and merge together some of these nasty little curves. So I'm going to say Combine Curves. And I turn it on. And let's try this one here. Now, when I do this command, it's actually going to remesh this solid here. You can see I've got a different Jacobian, a different mesh. And the other important thing is what happens in the message window, because it'll tell you, okay, you've got an indicator of element quality. So that particular command didn't make it better. I'm going to use Control-Z to undo, and we could try something else. Maybe we're going to pick this point here and try and merge these together. Now be aware that since it is remeshing the whole solid, for more complicated solids, it's going to take a while. Alright, so it's remeshed. I've gotten rid of that problem area. I've got another one over here. And obviously for a real project you can chase these all day. We'll just do a few examples. So combining curves is really useful. The other command I find really useful is mesh sizing. So let's say we just need to add another element here. We're going to increase that element size by 1. There we go. We've added an element. It's remeshed. And look, our mesh quality has improved again. So I'm going to say it again. We have entire seminars dedicated just to working with element quality in the meshing toolbox. If this is something you're struggling with, please check them out. Please email me, and we can give you some good guidance here. Okay, let's turn this contour off. We'll mesh our beam elements now. I'm going to turn off the meshing toolbox as well. So let's say Mesh Geometry Curve. And I'm going to pick my curves here. I'm going to pick my tube property, and I'm going to give it an orientation. Your beam element orientation cannot be along the axis of the beam. So I'm using the global X direction. That's perpendicular. That'll work just fine. Okay, so you can see this thin red line here. My beam elements have been created. If you want to preview the cross-section, this view style cube is really useful. So this is on the View toolbar. I highly recommend using this thing because you do the little drop-down menu. You've got all sorts of good options here. You can turn off your mesh sizing, those little dots, if you find them annoying. You can turn on your thickness. You can turn on shading, filled edges. All this stuff is really useful. Okay, so it looks like that is just about right. So now I need to connect them to my solid mesh. So let's say I'll turn off my thickness. That might make things a little bit easier. And we're going to create these rigid elements, these multi-point constraints. And they're going to connect my beam element to my solid elements. Model element. And I'm going to switch type to rigid. Here we go, RBE2. Now my independent node, or my central node, is going to be sitting at the end of the beam here, so I can pick that right there. My dependent nodes are going to be all the nodes on this solid mesh. Now you could go in and turn off these degrees of freedom, and you would probably ask, all right, which ones do I turn off? Why do I turn those off? Again, check out our seminars. We've got one dedicated to multi-point constraints. These things can be massive time savers, and they can also sabotage your model. So it's really good to read up on them and know what's going on before you start using them. All right, let's pick our dependent nodes. And I'm going to pick on surface. There we go. Rather than picking them one by one, I say I want all the nodes on that surface there. There we go. So it's a white element on a white background. It's a bit hard to see, but it's this little spider web here. And that's why sometimes they call them rigid spiders. So let's do the same for our other three connections. Sometimes if you have trouble picking a surface here, you can see I can't quite pick that surface. You can switch modes. You can right-click, pick front. So that's picking what's directly in front of the mouse. So that's pretty useful. There we go. There's another one. Let's make our last few up here. If you don't want the white elements on white background, you can always choose the color here. Let's say we want dark elements, thick lines, something like that. All right, I'm going to say on surface, here and here. You don't have to hit preview every time. I just think it's kind of useful. Here we go. You can see that one's got my new color. And last one, zoom in, grab that, pick nodes on surfaces, and there we go. All right, so I need one more, and I need one more to apply my load. So let's go ahead, back to our selector, turn on all our solids, and show everything. I want to use this solid and this solid. I'm going to show just those two. Because I'm not going to model this solid, but that's where my load gets applied. So I need this solid out here because there's a little point out here where I want to apply my load. And then I need this solid because that's where it connects in. So let's make one more rigid element. Model element. Our nodes will be on surface, and I'm going to grab the inside surfaces of these holes here. There we go. I could probably pick a few more if I wanted to. There we go, preview. That's why that preview button is so useful. Okay. Now my independent node, I don't have anything to pick on out here, so I'm just going to leave it blank or leave it at 0. And when I click OK, Femap will automatically prompt me, say, hey, this doesn't exist. Do we want to create it? Yes. So now I get to pick where to create this new node. It remembers my midpoint picking option from last time, so I'm going to switch back to locate. That's our default. And there's going to be a geometric point here on this solid. So I want to say snap to point. So I pick right there. I click OK. It has created my element. So it created a new node for me and created that element. So now I have a highly idealized little lever arm here to pull on. Okay, looking through our analysis workflow, geometry, material, property, mesh size, meshing. Now we just need boundary conditions, then we can analyze. Boundary conditions for this are going to be pretty simple. I'm going to do a load nodal. I'm going to pick this node here that we just created, and we're going to pull on it in the X direction. Let's say we'll pull on it with 100 units of force. All right, now let's do the same thing for our constraints. Model, constraint, nodal. What I want to do with these is I want to pick the nodes along my beams here where I went ahead and broke those curves. So that's why I broke the curves in the first place, so I would have nodes right where I wanted them for my constraint. We'll just say those are pinned constraints. If you want to see your nodes and constraints and they're not showing up on screen, come back to visibility, and you can realize we don't see them because they're not turned on. So we can turn on everything, maybe selectively remove things from the view here. There we go. So there's my constraints, there's my load. We are ready to analyze. Now, for the analysis, there's only one thing that I want to change, only one modification, and it's on the very last page. So you have to walk through all these pages here for the analysis options, and you come here. And I want to request force balance. And I'm requesting this information so that I can generate a free body diagram. And we're going to analyze. You guys can all hear the wonderful things going on outside my window. We have trains and traffic, cars honking, so I apologize for that. Maybe my microphone won't pick up on too much of it.